Good morning, guys. Welcome to another episode of Xa Talk Show. Today we are going to code Wolfram language live. So this is mostly going to be me working on my Wolfram language package, and probably it's going to be boring for you, unless you are interested in Wolfram language, which is the fantastic, greatest, my favorite language. So I'm going to, this is a Wolfram language coding session for myself, working on my packages. And in this 1 hour or so, I'm going to, as I work, I'm going to explain some things about Wolfram language, and that's it. But first of all, let me give you a short introduction. So if you just search for Xa Wolfram language tutorial, you can see my tutorial. And I've done several videos about it, like over 10, 20 videos in the past year, introduction. And you can get it for free, download for free. And then you can learn the language, Wolfram language basics and Wolfram language, Wolfram research website, they have like 1 million pages of documentation. So let's, I'm just going to work on my Wolfram language now, okay? So this today's talk show, Wolfram language tutorial. So you know where to get it for free, and explain the notebook format, okay? First of all, let me explain the notebook, the Wolfram language notebook format, okay? So you start Wolfram language desktop, new notebook, and let's say 3 plus 2, 3 plus 7, okay? Enter 10, and let's magnify. So you got a big, so this is a notebook. Now a notebook is just like, let me show you, okay? So if I save this file, save, okay, untitled, let's save in desktop, okay, untitled 1, save. Now let's go to desktop. So you can see, refresh, here is the file. Now you can open the file. You see Wolfram language is the notebook, this is a notebook file. The raw, it's basically essentially just ASCII, just text files. And the content of the file is just pure Wolfram language code, okay? So for example, this thing, this parenthesis, star, something, that's a comment, okay? That's a kind of a nested syntax for comment. So you can delete that. So first of all, they have a bunch of comments. They tell you what's the content type, Wolfram notebook file, Wolfram research website, created by Wolfram desktop. That's the software I'm using. It's kind of confusing. You have Wolfram, so you have, let's see, download for free Wolfram engine by Mathematica. And what's the difference between Wolfram language, Mathematica, Wolfram engine, Wolfram script? It's a bit confusing. So, but essentially they are all the same. They are, Wolfram research, they pretty much have just one main product. That was called Mathematica, but now they call it Wolfram language, not referring to the language. The language is just like a Lisp. Okay, let's get back. So essentially it's just one thing, okay, one thing. But this page explains Wolfram language, Wolfram engine. Wolfram language refers to the language, like JavaScript, Perl, Python, Ruby, refers to the language, syntax and so on. And Wolfram engine is the software that actually do the computation. You might think of it as a compiler, that's a Wolfram engine. When you type 3 plus 7, it sends, the notebook sends this text expression to the Wolfram engine. The Wolfram engine do compilation, do parsing, compilation, whatever, return the result and send it back to the notebook, and the notebook displays 10. So that's what Wolfram engine is. And Wolfram script is just Wolfram language where you run it in shell. So let me show you. Okay, I have it all set up. For example, let's say let's save this file xx.wls. Okay, so you can see here is the file xx.wls. That's one of the file name extension for Wolfram language. So let's do something more. Okay, let's do 3 plus 4. Okay, and I can run it. I'm using XA Wolfram mod. Opening output file, permission denied. What? Let's see. 7. So you can see you see the result is 7. Let's do something more fancy. Okay, expand x squared times y, let's magnify, plus z third power. Okay, let's say square root of z plus y. Okay, let's say something like that. Z let's say x plus y. Okay, then square the whole thing by 4. Okay, now let's remove that and run this. Run it. Okay, so you can see the answer in the mini buffer. So here is the result, and you can do the same thing in the notebook. Let's do it here. You see, fantastic. And you can, let's copy it, and you can press Ctrl-Shift-N to make it, two-dimensional format, mathematical typesetting. Evaluate, same answer. So that's the notebook. And what I'm doing here in Emacs, because I have a XA Wolfram mod. Okay, let me show you. There, XA Wolfram mod. So you can go to the source code. So this is a Emacs Lisp major mod I wrote for the Wolfram language. You can get it. It's free. It's sponsored by Wolfram Research. So it allows you to code Wolfram language in Emacs. And it's on GitHub, so you can, so I have an introduction video. It's on GitHub. You can get it there on GitHub. Okay. So that's how I run. Let's not close it. So okay, so close that. Okay, let's show it and close that. Reopen, close. Okay, so here's an Emacs buffer, and it contains Wolfram language code, and I can run it. Run. You see the result is in the mini buffer. Can you magnify the mini buffer? Mini buffer is hard to magnify. Yeah, so it's better just to open the messages buffer to see the result. So you can see there is a result. Okay, close it. So I was talking about Wolfram language. That's Wolfram language, and that's Wolfram language. That's Wolfram language. Wolfram engine is what computes these things, and you can actually get the you can get for example, I can show you where is the actual Wolfram engine file path. So GCM is PowerShell. It stands for get commands. Okay, getting complex. Let's say let me show you. Okay, so PowerShell help GCM. GCM is the alias for get command. Okay, so I can type GCM Wolfram. Okay, Wolfram script executable. So you can see it's an application. Does it show the path? No. So you let's do format list. FL is a shortcut. FL is a PowerShell alias to the command format list. So get command Wolfram language. So you can see it's located here. C, I'm on Windows, so it's on C program files, Wolfram research, Wolfram script. So let's go to that directory. So so I can show you some of the Wolfram language compilers and executable. So let's paste the path here. One of the problem of the PowerShell I don't like is that it output this readable format, but however it's not so useful if you are coding, because you have to reconnect the lines. So anyway, here's the file path. So let's go to the directory actually. So let's go to the directory. So you can see here's a Wolfram language, Wolfram script directory. Go up a directory. So you can see C program files. I don't know if you can see that. Okay. So program files, Wolfram desktop, that's a product, they send it to me, and Wolfram script is free. So that's the executable. So close that, go to the Wolfram desktop and version 12.2, open, then you have Wolfram desktop executable, wolfram.exe. So let me tell you what these are, okay? It's a bit confusing, actually you don't need to know. So, but basically the Wolfram desktop you are seeing, that's what runs the notebook. That's the application. For example, let's open it. Let's try to open it. Open it. There it is. And I can now open a new notebook. That's a Wolfram desktop. Close that. I want to make sure I only have one instance running. Yeah, okay. So that's a Wolfram desktop, and this is just a config file. And wolfram.exe, that's these two are similar. Basically, these are the actual kernel, the compilers that computes Wolfram language. So in Notebook, when you press enter, when you press Shift Enter to do some computation, it actually sends the expression to the Wolfram, to this Wolfram kernel. So it works kind of like a server client model. So the notebook is a client, sends the expression to the server, the kernel. The kernel, the Wolfram kernel can be local on my machine, or it can be far away, 10,000 miles. Or it can be a supercomputer, machine farm, things like that. And the Wolfram kernel returns the result, and it's displayed in Notebook. And similarly, in Emacs, for example, we've done Wolfram language. For example, we have done. Let's comment this out. For example, we have done this computation. It's doing similar things. It sends the expression to the kernel, and the kernel replies, and Emacs receive it and display the result. Okay, so let's go back to the directory. Yeah, okay, so that's Wolfram kernel. And Wolfram script is, I haven't showed Wolfram script. Wolfram script is the front end that allows you to do Wolfram language in a terminal. So for example, let me show you. So Wolfram, let's start it. It's just like any Python command line interface. So for example, let's send this expression to it. Paste, do it. So it, that's a Wolfram script. So Wolfram script is the command line interface. Wolfram notebook is the graphical interface. And you can also run it in Emacs. I'm using XAR Wolfram mod. Okay. So that's about the differences. What's the Wolfram language, Wolfram engine, Wolfram script, Wolfram notebook. What kind of a bit confusing. And Wolfram Player is basically just a free notebook-like application that allows you to see, if you downloaded some Wolfram notebook file online and you don't have Wolfram language installed, then you can download Wolfram Player just to see, to see it, but you cannot actually compute it. So Wolfram Player is kind of like marketing tool, okay? Not recommended. You rather, I recommend you just download Wolfram language, get the engine free, get the Wolfram script free, and if you want the graphical user interface, it can show fantastic graphics. You can download, from GitHub, it's open source, download the Julia. So did I mention it here? Yeah, so Jupyter, not Julia. So Jupyter, you download Jupyter, you run the Jupyter notebook, then you can, so that's another interface to Wolfram language. You run the notebook in the Jupyter, in the Jupyter notebook software. And whenever you want to do some computation, Wolfram language expression, you press enter, it sends the expression to the Wolfram kernel, the Wolfram engine, like we talked about before, and send it back to the Jupyter notebook, and you can display the graphics. You can rotate it, I believe. So anyway, that's introduction to these things, okay? And now I want to talk about the notebook. I want to show you what is the notebook file format made of. Okay, so you can see here's a notebook. Let's save it. Okay, let's open a new one. 3 plus 7. Okay, 3 plus 2. Okay, 5. Let's save this as xx.mb test notebook. Okay, now we go to the directory. So there is the test notebook, so open it. So like I said before, all these are just simply Wolfram language expressions. These are Wolfram language syntax. So all these are comments. All these are comments. You can delete it. You can actually delete it. The cache ID, internal cache information, notebook data position, those are cache. Any comment you see in this file is Wolfram language. Nothing extra. It's just pure Wolfram language. So, when you see a comment, you can actually just delete it. So let me close the notebook, close it, okay? And let's edit the notebook. Let's do like surgery, some like programming, engineering, software code. This is surgery. We modify the notebook directly by just using Wolfram language. Okay, so it says beginning of notebook content, deleted, and then end of notebook content, deleted, internal cache information, deleted, cell tag. Those are caches for whether the cells are closed or not. Things like that. So we can also delete it. So here you are actually seeing the raw Wolfram language for the simple, for the most simple computation, 3 plus 2. Okay, let me explain how this is. It's kind of confusing, but let me explain. You'll understand. So you can see the notebook. This notebook is a function. Okay, so that's a function. Notebook, yeah, so that's just a function like that, and the notebook takes it takes 2 arguments. So you can see the first argument is this part. It's just one curly bracket. That's the first argument. Then it takes several more arguments, rest arguments. So it says window size. Window size is is the window size, not important information. So window size, window margin, magnification 1.4 because we magnified the notebook. Then front end version, 1.2.2 for Microsoft Windows, 64 bits. style definition, default, style definition. That notebook is, so it's like you can use kind of like CSS thing to control the look. You can have headers, subheadings, subsections, and so on. I'm gonna go over, okay? Then expression, expression UUID. UUID is a universal identification that they just give a random number for this particular notebook. So let's modify this notebook, okay? So first of all, notebook, then this window size we don't care, okay? So remove all that. So now the first argument is the actual real content of the notebook. So let me dissect how this works, okay? This cell group is very annoying. So you can see, so this is the first argument, and this argument is a list. How do I know? Because a list, that curly braces, that's a syntax for a list. So this list has only one element. Yeah, only one element, cell. Now you see it's all nested, just like Lisp. This is Wolfram language is just Lisp. Okay, it's one of the, it's just a Lisp. So it's all nested. So this notebook takes one argument, the first argument. Okay, so you cannot have extra comma here, so you need to remove that. So one argument, a list, and this list consists of just one element, cell. So one single cell. So what is a cell? Cell is this thing. So if you type that, it creates this. That's a cell. Okay, so that notebook has only one cell, not this one, but the one we just closed. Can we reopen? Let's see. Control Shift Tab. We're gonna reopen later. Okay. Actually, let's reopen now. So save this file. Go back. Go back to the. You see, we reduced the file size by a lot, and open it. You see, there is our notebook again. So, but let's delete it. Let's again, let's work on. Let's modify the. The source code, the raw content of the notebook. So, and you can also program the notebook. You can generate the notebook programmatically. You can generate lots of notebook. So anyway, cell. So this list has one element, and that element is a cell. And this cell has how many elements? 2 elements. Okay, so this cell is another function. It takes 2 arguments here. So let's say, just one argument. So you see, this cell is just one argument, and that argument is the cell group data. It gets a bit tedious. The cell group data takes 2 arguments. So the first argument is a list again. The second argument is open. So what does open mean? Open means, if you have a cell here, that's open. This is close. You see, you can expand it. That's open, close, open, close. This one, close, open. Just like org mod, you have hierarchy of headers, heading 1, heading 2, subheading 3, heading, subheading 4. You can expand them or, open them or close them. Similar, very similar. For example, let me show you. So heading, let's see, heading 1, okay, heading 1, heading 2, heading 3. So you create a cell, you select it, you go to the format, and you can go to style. So you can see, you can choose title, old 1. Then it becomes that. Then old 2 is the subtitle. Let's old 2 subtitle. Old 3 is chapter. So they give different names, but you can think of it just heading 1, heading 2, heading 3. So let's see, let's make this old 3. So the way they named it is old 1 is title, old 1 is title, old 2 is subtitle, old 3 is chapter, old 4 is section. title, subtitle, chapter, section, subsection. So let's Alt 3. Let's see, Alt 3. Then this is Alt 4. Then heading 5. Alt 5. Let's do Alt 5. So you can see. So now you have them. Because we set their style. So you have heading 1, heading 2. They become a hierarchy. So you can collapse the whole thing. You can collapse any root of the tree. So it's just like org mod. But let me go back here to explain. Okay, so this cell group data you have open, then you have the first argument is a list here. The second argument is just open, meaning the cell is open. Okay, so you have cell group data. Then you have actually started to have a cell. Okay, cell takes two arguments. So you have the first one is a box data. The second one is box data. So it gets complex. It gets tedious. So let me just simply explain what are these. You don't need this. Okay, So what are these box data? Let me explain. Okay, so when you have something simple like a number, then you're gonna have, for example, let me show. For example, we can create an entire new notebook. Let's do it by we're gonna manually create an entire new notebook, like that. Okay, so let's so first of all switch it to Wolfram language mod, Wolfram language mod, then completion notebook. Okay, so notebook is represent the notebook. Then you have a cell. So let's create a cell. Then in this cell, let's say 3 plus 4 plus 5. Okay, so that's it. That's one notebook. So we can save it. test2.mb. Okay, so you can see here is our file test2.mb. So that's it. Now let's open this file. So let's open in desktop test2. Open it. Okay, I got the syntax wrong. That's why it's not showing. So let's modify it. I think this should be strings. No, they shouldn't be strings. Let's say cell group. Let's just do whatever the other thing is doing. Let's see, cell group data. This is complicated. Let's just put them into a string. Let's see what happens. Okay, save it. Open it. Okay, it's not showing. Okay, so close it. Let's okay. So maybe you need cell notebook. Okay, notebook. Oh yeah, you need the list. I suppose. Let's see. Let's look at the documentation. Okay, Wolfram language notebook documentation. The notebook function. Refresh. Yeah, so you see notebook, the syntax, you need a list. That's why we got it wrong. So you gotta have a list here and put the cell there. Okay, save it. Open it. Fantastic. You can see 3, 4, 5 there. You see, we manually created a notebook. So close it. So the main point I want to make here is that the notebook format is just, the content of the notebook is just pure ASCII text text, okay, pure ASCII text, and the content is purely Wolfram language expressions, nothing else. You don't have binary, special format, or maybe backslash, maybe backslash for bold. You don't have nothing like that. The whole syntax is, the notebook syntax is just Wolfram language, okay? Now in Wolfram language, you have things like this, notebook cell that represent, this kind, this thing. And when you evaluate this in a, when you open this Wolfram expression in a notebook, then it format them nicely. And also you can actually run this code. I can actually run this code right now. But before we do that, let's make sure my syntax is correct, okay? So the notebook requires one argument of a list, okay? And then inside the list, each element is a cell. So what exactly should the cell be? Notebook file contains explicit notebook expressions written out in a textual form. You can manipulate open notebooks in the front end using standard commands in the front end using the open inspector, and so on, okay? So okay, let's look at the cell function. So you see, it says cell is a low-level representation of a cell inside a Wolfram system notebook. Okay, so contents and style. Okay, so we need a style. So, okay, so we need a style here, because otherwise, when we, because otherwise we open a notebook, it's can we actually evaluate this? You cannot, you see. So you see, normally you press shift return to evaluate, but this is what's called inactive cell. Inactive cell is just for representation. You cannot actually evaluate. So in other words, you have tags to represent which part is the expression that actually is hot, like code. For example, in org mod, you have certain tags that to signify this part is actual code. So when you run it, part of the org mod section will actually run as some code. In the same way, Wolfram language has that. So you see this cell represents a cell, but however you need to say style, like indicate whether it's active, expression or not. So what is the let's see, what is the syntax for the, I don't know. So what we can do is let's say options. So we want to see all the options for the function cell, okay? Okay. Oh God, cell has 1,000 options. What the hell? Jeez. You see, the cell, it's funny because cell it's a function, but it's a representational function. So let me show you this. This is interesting because the connection between Wolfram language and Lisp gets into lots of interesting things, and also HTML and XML. So let's see, sorry, HTML5. So I have an article. Yeah, I don't know where is this HTML tutorial. So go to my website, Xali Code, and click on search and type HTML6, not 5, right? So that's right, HTML6. Okay. So this is the article, HTML, JSON, XML simplified. So you can see Lisp is just Lisp syntax is nested list, and HTML and XML is also nested. So in some sense, they are the same. They are just nested syntax. So in the same way, Wolfram language is the same. Now in Lisp, usually when you have I explain part of it here. So for example, there are many formats existing in Scheme Lisp. In particular in Scheme Racket, they use Lisp expression to represent HTML. So this is how you represent H1 header, you see. So if you represent HTML in Lisp in this way, you'll see that this H1, this H1 technically is a function, but this function actually doesn't do any computation, except that when you have a program that renders this, this thing, for example, a browser, then H1 became meaningful. What it means is that whatever inside the H1 should be rendered in certain way, because H1 is a header. So this is how you represent HTML in Lisp syntax. Okay, and this is actually part of the standard. It's called Scheme. Did I mention? It's a standard. It's like very popular among the Scheme fanatics. The associated word is like semantic web. If you search for semantic web and Lisp, semantic web Lisp, you'll find the lots of standard documentations and proposals from mostly the Scheme Lisp community, especially during the year 2000s, lots of it, because that's the time when the semantic web idea is very hot. So anyway, but if you represent HTML in this Lisp, in a Lisp syntax, you'll see that some functions, they don't have some functions such as H1, they don't have a computational purpose. Rather, they have, so they are inert in some way. So if you run this in Lisp, compile, it doesn't do nothing. It just returns itself. But if you use some application like a browser or PDF, to load this document, then H1 is meaningful. It means that the following expression should be in bold, in larger font, and so on, because it's a header. So the point here is that you have some functions that's inert. Actually, that happens in Lisp right now too. For example, let's so we have Emacs Lisp. So we have cons, cons. Let's say 3, 4. Okay. Cons is a data structure. It's a fundamental data structure in Lisp, but the cons doesn't do anything. I mean, it doesn't actually compute. It just represents a structure. So in the same way, if you represent HTML in Lisp, you have this kind of thing. It represents a structure. By the way, these are alternatives. There are different syntax for different proposals to represent XML in Lisp. So this is one of them, and this is another one. They have competing proposals to represent XML in Lisp. So, but my point I want to make is that some functions, you will have some functions that's rather inert, such as the cons, in the same way here. So that brings up to the Wolfram language. So this notebook, that's a function, but it doesn't do anything. That's a point. Okay, that's a point I'm making. This cell is a function, but it actually doesn't do anything. It only represents some format, some structure. But if you open this thing, in Let's save it. Permission denied because I have this open. Close it. You know, on Windows, if you have something open, you cannot modify it until that's closed. So now, saved. Okay, now if I open, there it is. Okay, so actually it gives me an error, so we can see an improperly formatted directive with head symbol was encountered. Error occurs cell on line 3. Yeah, it's telling me that this is, there. You see, I got the style. You see the style, this is wrong syntax. So let's do it again. Close it. Close it. So now we can open this file. Open it. And what output error? Permission denied. What did we? Opening output file. Permission denied. Oh yeah, we are opening the wrong file. Jesus, what? Test 2. Untitled 1. So anyway, let's save this. Okay, save this. And back to. That's why. I see. Yeah, never mind. What was going on was that I have auto save in Emacs, so that it's actually trying to save this file. You know, because we opened it before, but I just closed it. But anyway, so no, so let's open it. Let's go to Untitled, close that. Yeah, so we open this file, and you know, so let's close it. So we get rid of that error. Okay, so let's open this again. There it is. Okay. Now I want to add a style. I'm not sure what is the format because we just tried the option cell and there are like 1,000 options. So let's cheat and let's just look at the other notebook. What is the? So let's cheat and let's see what style it's using. Expression ID, cell, box data, raw. This raw box, you know. So anyway, so you see what you are seeing here is the content of this notebook. Now it's getting too big. Okay, let's close this. What's going on? Yeah, don't save. Close it. Yeah, because I have auto save. Okay, finally. So now let's close this thing. Now let's just save that. Okay, let's close these two. Close, make them simpler. Save it. Now open it. What? Oh, untitled there. So there is one cell. Oh, there. Okay, so now I got it. So now what you need to do, not style, but what is it? input. Okay, so that's what you need. So this cell needs two arguments. The first argument is an expression. The second argument is what type of cell, like we mentioned before, active or inactive or whatever. So input, make it input cell. So that's when you want to evaluate something. And this, you don't need to be a string. Yeah, so save it. So remove that. You cannot have hanging parentheses. You cannot have, you know, trailing commas in Wolfram language. So there it is. Okay, so let's save it. Okay, open this file. Okay, error. Error. Okay, I think I need, why is it error? I think I need improperly formatted directive with head symbol is encountered. Line 3. Okay, improperly. Yeah, okay. So let's make this. I think it needs to be a string then. Let's make this. Okay, save it. Let's close that, close that, close that. Okay, open it. There it is. Fantastic. You can see Wolfram language. Let's see. Yeah, so this, let's make a backup. So this is what it looks like over there. I want to, so let me show you something here. Okay, so let's delete this and delete this. Let's just save this, and okay, and let's say 3 plus 4 here. Okay, and evaluate it. Okay, so this is kind of hierarchy. So save this. Now let's open untitled. Okay, so it looks like that. So you can see it's a notebook. Then you got a bunch of cells. So this is, oh yeah, okay, this is one giant cell. Okay, so the notebook, so oh yeah, so they create one giant cell to hold all these things. So you can see the heading 1 here, this one is this part. So heading 1, then title. Yeah, title is the style of this heading. Then, you know, cell change time, you know, it records when you make change to it. So because it has a stepwise backup systems, you know, you can, like many software today, you can revert to specific date you modified it. Okay, so the details are a bit tedious, but basically that's, you know, that's what I'm trying to tell you. So in summary, a notebook content is just text file, ASCII text file of Wolfram expressions. And you are looking at the content. So these expressions are just Wolfram language. And Wolfram language has many functions that's like Lisp's cons, or like how you represent HTML in Lisp syntax. You have many functions that's not for computational purposes, but rather they represent a structure or particular formatting of expressions. So for example, this notebook and cell. Okay, so then what I want to show you is that, okay, what I want to show you is this part. Okay, so input, let's say did we okay, so I want to have some fancy thing. Let's do that, okay? So let's paste that here. Okay, let's make several copies of it. Now I want to show you some formats, okay? For the first one, Control-Shift-R means raw, okay? That means don't format, anything. Just Control-Shift-R. Control-Shift-R, okay? Then this one, Control-Shift-I for standard input. What? Why is it? Control-Shift-R. I don't know why it adds a space there. Control-Shift-R. Yeah, it adds a space. Why is that? Control-Shift-I. It shouldn't add a space. Control-Shift-N. Okay, I haven't. Wow, a lot comment. Wow, thank you guys, and thank you Oflamio. I haven't seen the comments. I think that's it for today. I was gonna work on my Wolfram language and so I'm gonna read comments. You can read a Wolfram language notebook in Emacs with that mod. Yes, of course. You mean the Wolfram language mod, XR Wolfram language mod? Yes, that's what you are seeing here. Latest Wolfram version. I have to talk to them because I don't. I realized I have the version 12. Right now they are on version 13. So I need to talk to them to get me the latest version. But it should be the same, by the way. The Wolfram language, basically you can expect 10 years without changing any code, compatibility. You can read and write Wolfram language notebook in Emacs with that mod. Yeah. Opening Clubhouse shaved 10 IQ points. What? So Joman says, is it possible to run a program like a keystroke counter outside Mathematica while writing a web or docs? Yeah, of course. I mean, you have. How long have I been talking? 50 minutes. I think that's it for today. So, I was going to work on my packages, but explaining the notebook format took an hour. But it's a good thing because I wanted to explain this for a while. But there's a major point I want to get to. I want to show you some of the difference between. Let's see. Let's try it again. Okay, let's Control-Shift-R, Control-Shift-I, Control-Shift-N. There's a major part I want to show you guys. Okay, so let's do it again. Close that. So new, save, test3 MB. Okay, so I'm gonna show you this. 3 plus 1. Okay, let's make some copies of these. 3 copies. Okay, wait. Let's say 3 plus x squared. Okay. Copy, and the first one, Control-Shift-R. Let me show you what that is. Okay, you go to the cell. And you can say convert to. Basically, you specify what kind of representation or style. Okay, so you have Control Shift R for raw input form. That means represent this expression in plain ASCII. No fancy rendering, nothing. Just plain, the most basic Wolfram language expression. That's this raw input form. Okay, so Control Shift R. Then you also have Control Shift I for input form. That's also ASCII, but less raw. Raw is the most, the most simple. Then you have the input form. Then you have the standard form, Control Shift N. Okay, so let me show you one by one. Control Shift R, so that's the raw input form, the first one. Control Shift I, so the second one is input form. Then the third one is, let's do Control Shift N, that's a standard form. So that's why you started to see this expression, the raised. So let me also type some text. Alt 7. This is raw input form. Okay. Alt 7. This is input form. Then Alt 7. This is standard form. Let's just say standard form. Okay. So now save this. Now let's open them in raw. Let's see what they are. So test 3. So you can see. So you can see here it says this is raw input form text. Then you have the cell. You can see cell 3 plus x squared input. Okay, blah blah blah. Then you have this. So this input form, that's the first one. This is raw input form. Okay, that's this one. That's what this one. Okay, raw input form. So you can see the expression is here. The most simple possible. Okay, then let's look at the second one, the input form. This one. Okay, so go down. So you see it says this is the input form. Then you started to see, you see, notice this box data. This box data. Then you have raw box. Then raw box is a list. Raw box is a list of many elements. You have, a string 3, then a string empty space, then a string plus, then an empty space, then another raw box, 3, blah, 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 that's input. So that's the second one. Okay, that's this one. But, they look the same, but you might wondering, so what's with this raw box and so on? Because it allows you to, you see, when I click, it's syntax aware, because of these raw boxes, I can click and select by semantic unit, for example, click twice, 3 times, 4 times, but here I cannot do it. It just select the whole thing. You can see this when you have more complicated expressions. Anyway, so let's go on to look at the standard form. There it gets more complex. Okay, so you go down and you can see standard form. Then you can see, box data, raw box, superscript box. Oh, still pretty simple. Okay, so this is actually what you want. Anyway, so that's what I'm trying to do, is to explain what are these raw box and box data are for. They are essentially, like LaTeX, they represent, they kind of captures the position. For example, raw box is just a box of things. It doesn't represent any computation. It's trying to represent the position of things. That's why you have this raw box. So in other words, you are trying to have a format that specify arbitrarily complicated expressions like that in a nested syntax and also represent the position. So that's why you have this row box and superscript box things. But my point, the point I want to make is that if you want the things to be the most simple possible, just make them raw input form. But you miss a lot. Features. For example, this is the input form. This is the input form. This is the standard form. I can click on that and subsequently, depending on where my cursor are, subsequently expand the expression by semantic unit. For example, I can click on that, then I got the whole thing. Or if I click start here with a plus sign, see? So this is the standard form. This is the most normal. Now over here it's the input form. I can also do that. You can see I can start here, or I can start here, or I can start here. But over here it's the raw input form. You don't have that. You just select the whole line. Okay, that's anyway, so that's it. Oh, so how do you filter an array to exclude numbers less than 50? That's the most simple. Okay, so let me answer that. That's a good question. That's the most simple. So let's do a random random integer. Okay, random integer. Let's say 10. Let's say 10. Okay, 10 of them. Random integer under 100, okay, from 1 to 100 or 0 to 100. So we got 10 of them. So now let's set it to x. X, one thing I don't like is the Wolfram notebook doesn't have good text editing abilities. That's why I work in Emacs. So okay, so x is this bunch of numbers. So you want to filter out. So you can do it in many ways. You can. So when you have a list, this is a huge topic. So when you have a list, you can filter by a function or by a pattern. Yeah, in general. So basically, the cases is by a pattern. Okay, so not cases. Yeah, so if you want to do it by a pattern, then you just say cases x, then give a pattern. So the pattern should be, in this case, pattern is not suitable. It's more suitable if you give a function. But however, you can represent a function by a pattern. So the way you do that is you can represent a function by a pattern. Yeah, okay, so I need to look up the patterns syntax. Yeah, okay, let's just do select. Okay, first of all let's do select. Select is what allows you to filter by a function. Okay, so select x, then we just write a function. Let's say x, the function will be argument less than 50 true. Okay, then that, okay, that should do it. There it is. So this is a function. This is a function shortcut. So it removes elements beyond more than 50. And the full syntax for that, another way to write this is like this, more understandable. Function, so function argument, let's say x, let's use some other symbol. So y less than 50. This is another way to do it, same result. But you can also use cases. So the difference is that if you use select, you use a function to filter out. So the function returns true, it stays. It returns false, the item is removed. Or you can use cases. Cases, you use a pattern. If the pattern match, the element stays. So if we want to use a pattern, we need a pattern to represent any number that's less than 50. Now this is generally not represented by a pattern, because a number less than 50, but however, the pattern allows you to represent a function by a pattern, but I don't remember the syntax offhand, but I believe it's like this, okay? So you just say anything, let's just try it, okay? So you just say anything and question mark, then followed by the function. I think that's how you do it. Let's just try, okay? Do it? No. So we need to look at the patterns, okay? We should be able to do quickly. There's so many different ways to do this. Okay, I think that's it. Pattern matching functions, rules and patterns. Pattern matching functions. So what is a way to represent God? I forgot. Let's see. Let's try that. Patterns and transformation rules there. Okay. So here's a summary of the patterns. That is the function. Oh yeah. So the function needs to return true or false. So why is this not correct? Maybe we need a parenthesis. No. Oh, you need a parenthesis. That's why. Okay, there it is. So here is how you represent a function by a pattern. So this expression means it's a pattern. Okay, it's a pattern. The underscore means a pattern. Okay. The underscore means a pattern followed by a question mark. So that means this pattern underscore, it means anything. Okay, so you'll match anything except only if this function returns true. So so it's quite flexible. Cases, yeah. Okay, so okay. Thank you, guys. Bye, guys. Bye, guys. I rambled all over this hour trying to explain the notebook format, but it's not a good one. Okay, bye, guys.